Optical stealth technology. Have you ever fantasized about having the ability to become invisible? Have you ever thought about wearing an invisibility cloak and being able to freely shuttle through various occasions like Harry Potter? If you have such a dream, you may be interested in the latest research of Chu Juanhao, an academician of the CAS member and an expert in semiconductor physics and devices. He and his team have successfully developed a material that can achieve optical stealth, and even demonstrated the effects of stealth techniques on sight. According to academician Chu Juanhao, this magical phenomenon is caused by a cylindrical mirror grating. A cylindrical mirror grating is a material composed of tiny cylindrical convex lenses arranged in a regular manner that refracts light as it passes through it. This special structure allows the object behind it to be compressed into thin strips after light passes through. When there are enough lenses, the object will be decomposed into countless identical thin strips. Due to the inability of the human eye to distinguish these thin strips, the object appears to have disappeared. This technology is not magic, but pure scientific means. In addition to cylindrical grating, academician Chu Juanhao also demonstrated another stealth method, using two substances with similar refractive indices. For example, high borosilicate glass and glycerol have similar refractive indices, and objects made of high borosilicate glass can also achieve stealth effects when moving in glycerol. This method of using the difference in refractive index of matter to hide objects opens up more possibilities and demonstrates the magic of stealth technology. Optical stealth refers to the use of special materials or structures to prevent objects from reflecting, scattering, or absorbing visible light or other electromagnetic waves, thus achieving the purpose of invisibility. Simply put, it means allowing light to pass around an object without being affected by it, making it impossible for the human eye to see its existence. Optical stealth technology has broad application prospects in military, security, medical and other fields, but it also faces enormous challenges. To achieve perfect optical stealth, it is necessary to be able to accurately control the refractive index of light in different media, that is, the rate of change of light propagation in different media. This requires designing and manufacturing artificial materials with complex parameters and structures, also known as metamaterials. Metastructured materials are artificially synthesized materials with special properties that do not exist in nature. Metastructured materials are macroscopic structures composed of sub-wavelength scale microscopic units. By adjusting the shape, size, and arrangement of microscopic units, they can freely manipulate physical fields such as electromagnetic waves, sound waves, and heat flows. Metamaterials are the key to achieving optical stealth technology, but they are also a bottleneck that restricts their development. At present, the preparation process of metamaterials is very complex and expensive, and often can only achieve stealth effects for specific frequency bands or angles. To make metamaterials more popular and practical, it is necessary to overcome technical difficulties in their design, manufacturing, and testing. Academician Chu Juanhao has long been engaged in research on infrared optoelectronic materials and devices, and has conducted systematic and internationally influential research results in narrow bandgap semiconductor physics and ferroelectric thin film material device physics. In recent years, he has mainly engaged in research on new materials, new structures, high-performance new optoelectronic materials and devices, including metamaterials and optical stealth technology. Academician Chu Juanhao presented a metamaterial sample that can achieve omnidirectional stealth in the visible light range. This type of metamaterial sample is made of a polymer with special optical properties, which can cause total reflection of light on its surface, forming a perfect mirror surface. When this material is covered on an object, it can fully reflect the scene behind the object, thereby achieving a stealth effect. This material can not only achieve stealth against visible light, but also achieve stealth against other electromagnetic waves such as infrared and ultraviolet rays, and has high application value. Optical stealth technology is a cutting-edge technology with broad application prospects, which can be used in military, security, medical and other fields, bringing many conveniences and benefits to humanity. For example, in the military field, optical stealth technology can improve the concealment and survivability of weapons and equipment, enhance strategic deterrence and strike capabilities. By utilizing optical stealth technology, stealth aircraft, tanks, ships, and other equipment that are difficult to detect by radar, infrared, visible light, and other detection methods can be manufactured, thereby gaining advantages on the battlefield. In the field of security, optical stealth technology can improve the protection capabilities of important facilities and personnel, preventing them from being discovered and attacked by hostile forces or terrorists. By utilizing optical stealth technology, it is possible to create invisible curtain walls or camouflage nets that can block or camouflage important targets such as nuclear power plants, military bases, and government agencies, thereby reducing the risk of reconnaissance and attack. In the medical field, optical stealth technology can improve the delivery efficiency and safety of medical devices and drugs, enhance treatment effectiveness and quality of life. By utilizing optical stealth technology, invisible nanorobots or drug carriers can be manufactured that can avoid interference from the human immune system and blood circulation system, directly reaching the lesion site, thereby achieving precise diagnosis and treatment. In addition to the aforementioned fields, optical stealth technology can also be applied in fields such as architecture, communication, and entertainment, creating more possibilities and surprises for humanity.